Pluto's weird orbit was always going to cause problems. It crosses Neptune's path, and that's got some scientists worried about a possible crash. Guys like Neil deGrasse Tyson and Michio Kaku are talking about what could happen if those two smash into each other. So, how did Pluto get on this collision course? And what does it mean for us here on Earth? Pluto used to be a real planet, but got bumped down to dwarf planet mostly, 'cause its orbit is so messed up. But people are still super curious about it. Tyson and Kaku have said that Pluto and Neptune might hit each other one day, which could be bad news for our planet. Pluto takes a crazy long time to go around the Sun, like 248 years. It hasn't even made a full trip since we found it in 1930. Plus, its orbit is super oval-shaped, not round like the other planets. And it's tilted too. It crosses Neptune's orbit every 20 years. It gets closer to the Sun than Neptune sometimes, which is just weird. Pluto's path isn't a circle, it's more like an egg. That means its distance from the Sun changes a lot. It gets as close as 30 astronomical units, AU, but can get as far as 49 Australian dollars, almost twice as far as Neptune. Plus, its orbit is tilted compared to the other planets, making things even more complicated. When Pluto and Neptune's orbits cross, their gravity messes with each other, changing their paths little by little. With better telescopes, we can track Pluto better now. That helps us understand its orbit and how it might affect the solar system. A direct hit is not likely, but we're still watching because a crash could be a disaster. Even though Pluto is small and far away, it's still interesting. Why hasn't Pluto hit Neptune already? It's because of gravity from other planets. Since we found Pluto, astronomers have tried to figure out its path. It's tilted and oval-shaped, unlike the other planets. Even though it crosses Neptune's orbit, it's surprisingly stable. Scientists are still trying to figure out how Pluto, Neptune, and the Sun all affect each other. They use a bunch of math and fancy terms to predict their movements. They use things to keep orbit stable. It makes sure Pluto stays far enough away from Neptune to avoid a crash. Even though space looks random, there are rules that keep things in order. These rules stop Pluto from hitting Neptune or messing up its orbit too much. But even a tiny change in Pluto's position could change its orbit a lot over time. Scientists use computers to see what would happen if Pluto's path changed even a little bit. Back in the 80s, they found out that Pluto's orbit, even though it looks stable, can still be a little unpredictable. But even with that, it stays stable for billions of years, so there's some kind of order hiding in there. It's hard to predict what will happen with Pluto in the long run because of planetary orbits can be unpredictable. To get good results, they need super accurate information at the start, because even small mistakes can throw everything off. It's super important to understand Pluto's orbit, especially when we think about a possible crash with Neptune. It shows us how our solar system works. Pluto's orbit is a good example of how things that look random can actually balance out because of gravity. We need to keep watching and studying these things to figure out how we fit into the universe. Pluto's orbit shows how unpredictable space can be. Pluto's orbit is different from the other planets. Its oval shape leads to random meetings with Neptune. It's tough to guess what will happen in the long run. But gravity is super important. It keeps Pluto and Neptune apart, even though their orbits cross. It's a delicate balance of forces. Even though it's not likely, a crash between Pluto and Neptune would be huge and change how we see the solar system. Space is complicated, and Pluto reminds us that there's a lot we still don't know. Scientists are still studying Pluto to see how big planets affect its movement. It's all about understanding how things in space relate to each other and how their movements affect each other. Some famous scientists, like Neil deGrasse Tyson, have said that Pluto could hit Neptune someday. Tyson thinks that calling Pluto a dwarf planet was the right thing to do. He says we need to keep exploring and learning because Pluto's weird orbit shows that we still have a lot to figure out about space. Tyson and other experts are worried about Pluto's odd path. If Pluto and Neptune crashed, it would be really bad for the solar system. It would release a ton of energy, and the junk flying around could hit other planets and moons. Neptune's orbit could change, too, making the outer solar system even more confusing. Michio Kaku also studies space. He thinks that looking at things like Pluto's orbit helps us understand how space works. He says that by studying Pluto and Neptune, we can make space missions safer in the future. Kaku also says that gravity is super important for space travel because it can change how we explore other planets. Kaku's work tries to explain the basic forces of the universe, and that's why he's interested in Pluto's orbit. A crash between Pluto and Neptune could give us information of gravity. Even though it wouldn't hurt Earth much, it would be a chance to study how forces work in extreme situations. As scientists keep looking deeper into space, it's clear that planets can do some really unexpected things. By studying things like Pluto and Neptune's gravity relationship, we can learn about the basic rules of the universe. If we keep watching and studying these things, we can get closer to understanding the huge and complicated cosmos. The way Pluto and Neptune pull on each other shows how even planets far apart can affect each other. Their gravity can change their orbits over time, little by little. A direct hit is not impossible, so people are still watching and studying. Scientists think that if we understand these forces, we might be able to predict and avoid cosmic crashes in the future. Sometimes, interactions in space that look random can actually lead to stable patterns. Pluto is a good example. Its orbit looks random, but it's controlled by gravity. These forces keep Pluto from hitting Neptune, even though their paths cross. The balance between Neptune and Pluto keeps Pluto on a steady, but complex, path. It's essential to understand this balance to learn more about the solar system. As scientists study Pluto's orbit, they're also looking at other places. Systems with multiple planets help scientists learn how gravity can cause planets to line up or become unstable. There are no crashes happening there right now. Scientists are carefully tracking planets in crowded environments to understand the risks. Scientists are also studying planets that drift through space without a star. Pluto's weird orbit is helping researchers to understand the complicated forces that control our solar system. One of the coolest things about Pluto is how it interacts with the Kuiper Belt. That's a region past Neptune with lots of icy objects and dwarf planets. The Kuiper Belt is what's left over from the early solar system, and Pluto gets close to a lot of these objects. It's essential to understand how Pluto interacts with the Kuiper Belt to understand how the solar system formed. Other objects in the outer solar system also affect Pluto's orbit. Neptune's gravity affects not only Pluto but also other objects in the Kuiper Belt. Scientists have been studying these relationships for a long time, using computers to see how their gravity interacts. These simulations help scientists guess how stable the Kuiper Belt will be in the long run and understand what the solar system will look like in the future. Studying Pluto's orbit also tells us about the chaotic early days of the solar system. When the solar system was forming, the big planets moved around and scattered smaller objects. This probably changed how things were spread out in the solar system. The gravity of these big planets may have pushed some objects, like Pluto, into their current orbits, while others were sent off in completely different directions. By studying Pluto's orbit, scientists can better understand the forces that shaped the solar system billions of years ago. Another big thing to remember about Pluto is the Sun's gravity. Even though it's far away, the Sun still plays a big part in shaping the orbits of objects in the outer solar system. Over time, the Sun's gravity has a small but impact on Pluto's motion, affecting its orbit. This is just one of many things that keep Pluto on its path. Studying Pluto and its orbit isn't just about understanding our solar system. It also has to do with space travel. As we get ready to send missions to far-off worlds, understanding how objects like Pluto behave and interact with other objects will be important for planning safe missions. Knowing about gravity will help astronauts travel. So, how did Pluto get on this crash course in the first place? And what would it mean for us? Pluto used to be a full-on planet, but then they changed it to a dwarf planet mostly, because its orbit is all over the place. Even though it's not a real planet anymore, Pluto's still super interesting to astronomers. These scientists warned us that Pluto's path might intersect with Neptune's, which means a potential collision and maybe problems for Earth. It takes Pluto a crazy 248 years to go around the Sun once. Since we found it in 1930, it hasn't even made a full circle. Plus, its orbit is super oval-shaped, not round like most planets. And it's tilted at a weird angle compared to the other planets. Every 20 years, Pluto's orbit crosses Neptune's. Pluto actually gets closer to the Sun than Neptune does during these times, which is unexpected. Its oval-shaped orbit means its distance from the Sun changes a lot. At its closest, it's about 30 times the distance between Earth and the Sun. At its farthest, it's over 49 times that distance. The fact that Pluto's orbit is tilted also messes with things. When their orbits cross, they pull on each other with gravity, which slowly changes their paths. This shows how everything in the solar system is connected. With better technology, astronomers can track Pluto's movements more precisely now. We know more about its orbit and how it might affect the outer solar system. Even though a direct hit is unlikely, scientists are still keeping an eye on things, because the consequences could be huge. People wonder, why hasn't Pluto already crashed into Neptune? It's because of the gravity from other planets. Since Pluto was found, astronomers have tried to figure out its path. Unlike other planets with consistent orbits, Pluto's is tilted and oval-shaped. It crosses Neptune's path, but it's still pretty stable, which is amazing. It's tough for astronomers to study Pluto-Neptune and the Sun and how they interact. To figure out their movements, you need to know how they affect each other. Scientists use terms like ASMU libration, latitude libration, VSOP, and Steves and Kaplan isolation to solve this puzzle. ASMU vibration helps keep planetary orbits stable. When Pluto crosses Neptune's path, it stays far enough away to avoid a head-on collision. Latitude vibration makes sure that when Pluto gets close to Neptune, it's above their path, reducing the risk of a crash. The VSOP stuff explains why Pluto's orbit looks weird but stays stable. Even though space seems like a mess, there are patterns that keep things in order. These patterns stop Pluto from hitting Neptune or messing up its orbit too much. A small change in Pluto's position or speed can make a big difference over time. Scientists use computers to simulate how Pluto interacts with other stuff in space and what would happen if its path changed a little. In the late 80s, they found that even though Pluto's orbit seems stable, it can be unpredictable. A tiny change in where Pluto starts could cause big changes to its orbit later on. But even with these unknowns, Pluto's orbit stays stable for billions of years, so there's some order to it. It's hard to know exactly what will happen with planets like Pluto in the long run. These models need really accurate info at the start, and even small mistakes can mess up the results. Understanding Pluto's orbit is important, especially if we want to know if it might hit Neptune someday. It helps us understand how our solar system works. Pluto's orbit is an example of how things that seem random can actually balance out because of gravity. We need to keep studying this stuff to get a better idea of our place in the universe. Pluto's orbit shows how unpredictable space can be. Its oval shape can lead to unexpected meetings with Neptune. It's hard to predict what will happen in the long term. But gravity makes sure Pluto and Neptune stay apart. These interactions show how balanced things are in space. A collision between Pluto and Neptune is unlikely but would be a huge deal. It would change what we know about the solar system. Even though we've explored a lot, Pluto's orbit reminds us that there's still a lot we don't know. Scientists are still studying Pluto's path to understand how big planets affect its movement. This helps us understand how everything in space is connected and how their movements can affect each other. Even some famous scientists, like Neil deGrasse Tyson, have wondered if Pluto could hit Neptune someday. Tyson sees Pluto's reclassification as a good thing. He thinks Pluto's weird orbit just shows how much we still have to learn about space. Tyson thinks that the mysteries of space are what make it so interesting. He and other experts are worried about the possible dangers of Pluto's path. If Pluto and Neptune collided, it would be a massive event with huge consequences. The energy released and the debris flying around could affect other planets and moons. Neptune's orbit could even change, making the outer solar system even more complicated. Michio Kaku, who works on string theory, also thinks studying Pluto's orbit is important for understanding how space works. He says that studying how Pluto interacts with Neptune can help us plan safer space missions in the future. Kaku also says it's important to understand gravity because it can change how we explore other planets. Kaku's work on string theory is related to his interest in Pluto's orbit. A collision between Pluto and Neptune could give us new info about gravity and spacetime, which are important in string theory. Even though it wouldn't affect Earth much, it could help us study gravity in extreme situations. As we keep exploring space, it's clear that planetary interactions can be unpredictable. Studying things like the relationship between Pluto and Neptune helps us understand the basic rules of the universe. By studying these things, we can learn more about the vastness of space.